when we're talking about Matplotlib, right, we have discussed things like figures, how do we place things on figures, how do we think of the API, but let's get into it. How do I draw things? And so when we go about drawing things, we have touched a little bit on primitive artists, but I really want to drill the point home about these artists, these things that know how to draw themselves in Matplotlib. Matplotlib has various primitive artists. You can look at the patches, you can look at lines. Patches are simply any closed polygon that has a fill to it. That fill can also be transparent, by the way. But your other primitives like lines, there are text, there are annotations. These are things that say, hey, I have a color, I have something to say here, I have something to put actually on the plot. I'm not just a container, right? I actually have attributes that are meaningful to the canvas in terms of where something will be located, in terms of what something will look like, and in terms of what to actually draw. And so if we instantiate our empty figure here, and I want to draw a circle on that figure, I can just simply make a circle patch, right, from matplotlib.patches, and I can tell Matplotlib, hey, add this to my figure. And you can see here, I haven't really made a circle, I made a quarter of a circle. So maybe we need to investigate some of the parameters here and take note that this is actually the XY coordinates of the center of the circle. And so we can actually update our circle here using the set method and change its center to 0.5.5, and we see that we end up with this circle. Now, if you're watching this and you're thinking, Cameron, that's not a circle, that's an ellipse, that is just because I have my Matplotlib screen maximized by default, so we're just seeing some stretching here. We can also add other shapes like a rectangle, right, with the same logic. And if we add a rectangle manually, we can see we draw it in the lower left corner. We give it a different color than we gave our circle. We can even draw a line, right? And this line, I chose to draw an exponential curve here. And so we can see here that all Matplotlib does under the hood, every single call that you do to .plot, to .bar, to .scatter, it's just Matplotlib iterating over your values you've given it and drawing a circle, adding that circle to the figure, or probably to the axes more likely, adding a rectangle, right, for our bar plot. And then what it does is it returns those artists to us. But if we want to draw a little bit more complex things, we can. We can do this explicitly. We can take control away from Matplotlib and do this ourselves. We can create our figure and our axes. We can set our x limits, our x and y limits, I should say, and we can actually iterate, from 1 to 5 not inclusive. Draw me a rectangle and then put it at that position and give it a height of 1. And when we do this, we end up with something that kind of looks like a bar plot. And on our bar plot, and if you've noticed, I've kept track of all the artists I've added, and I end up with this list, right? This list of rectangles that I've decided to add. And we can even, like I showed earlier, we can update the coordinate system, or the coordinates of these rectangles that I've drawn to get something just a little bit more aesthetically pleasing. And what you'll notice here is that if I were to draw the same exact bar plot, and I won't add the artists here, I'll add them to the list. If we were to draw the same exact bar plot using the ax.bar method, we get the same thing I was just looking at, right? Yeah, it's not shifted over to the right, but this is the exact same as the first plot I showed you. And if you inspect the output that's below, bars is the thing returned by calling ax.bar. Artist is the thing that I manually set up by adding rectangles into a list. You'll notice that a bars is an object that's a bar container object that has 5 artists in it, and the explicit list that I made with artists is a list that's 5 objects long. These are practically equivalent. Matplotlib is just returning us a list of bar artists in its own container that has some just convenience methods for setting properties on things, but this effectively, I can index into this just like I would a list, and when I index into it, I control specific parameters of the primitive, of the first rectangle drawn to screen. And that is how you can orient your thinking of Matplotlib. We use these convenience methods to generate artists, to generate primitives that are actually drawn to the screen, and I can slice and dice, I can change them in any fashion that I want. In this example, I'm drawing us a nice little sine wave here. The same idea, right? ax.plot returns me actually a list of lines, so I can add those lines into some other variable or some other list. And you can see that my ax.lines is a list of one artist, my children. You can actually see that line 2D object that I have added into this plot here. And you can extend this thinking about, instead of iterating manually over my data, I can actually, let me remove this. I can actually iterate, instead of over my data, I can iterate over functions. I can draw more than one thing. And I can keep track of those artists myself. I see that ax.lines is 2 artists, ax.children now has 2 lines, right, pre-appended to that list of things that are drawn. And I can see that Matplotlib is keeping track of everything that I'm drawing to it. But it's also returning to me the ability to keep track of those myself. And by doing that, I can tap into each of these artists and change things as I want. And so if I were also to plot to a sine and cosine wave, I don't need to do any iteration. If I just use a little bit of NumPy logic here and create these values such that I'm storing 2 columnar arrays or a 2 columnar array as x's and a 2 columnar array as y's, Matplotlib will line up these arrays for me and do my plotting. And the reason I bring this up is because Matplotlib isn't just an exercise in thinking about artists and things of that nature, but it's thinking about how does our data look and how do we want to represent it. If I know that I'm using columnar arrays to draw two different waves, I can think Matplotlib is connecting each of the paired points, right, within these 2 arrays to draw something. And if I extend that thinking just a little bit, I can draw the transpose. And what this will actually do is now I'm drawing lines that span the space between my sine and cosine. It's, like I mentioned, it's not an exercise in just thinking about artists, but it's an exercise in thinking about the way your data is shaped and how the artists will interact with that, how the way your data is shaped will affect how your graph is drawn, because Matplotlib has to make a decision somewhere. How does a 2D array, or 2 2D arrays, how should that be represented on a plot? Now, given that Matplotlib does transformations for us, right, it has to map some type of data, right, from 0 to infinity or from negative infinity to infinity into a bounded window that usually spans from 0 to 1 just for convenience sake. And so what we can do here is we can actually use transforms, Matplotlib transforms, to specify certain features of our plot. And what these transforms do is all you're doing is telling Matplotlib, when I draw a line on this axis and I specify my x values as 0 and 1 and my y values as 1 and 0, I don't want you to draw it on the data coordinates, right, from 0 to 1. I want you to draw on the axis coordinates from 0 to 1. That's the start and end of my axes. You'll see that when I plot this plot, there's this nice diagonal line going from the top left to the bottom right here. And that's what the transforms give us. It gives us a way to add features, add artists onto our plot without having to worry about the underlying data coordinate system on the underlying plot and just say, ignore the data coordinate system, just use this axes coordinate system. So your transforms are really all about thinking about coordinate systems and the multiple coordinate systems that Matplotlib has to manage in order for it to work. You have things like a coordinate system on your axes, right? 0 to 1. You have things like a coordinate system on your figure that we've discussed, also 0 to 1. You have a data coordinate system on your axes. You have a pixel coordinate system on your axes, a pixel coordinate system on your figure, right? How do I map these small dot-based units to an actual pixel? And that will actually give you control over the physical representation of your plot. If you want to do something like draw a circle that's always 200 pixels in width, no matter how I resize or reshape this plot, Matplotlib gives you the ability to do this via transforms. So whenever you want a feature or something to span your entire plot or to be locked in place at any given moment, no matter how you stretch it, transforms in Matplotlib are the thing that you reach for. And you can even use this idea to highlight or draw things on your plot. Here I'm highlighting that I'm going to be drawing a rectangle that goes from some coordinate on the data system, on the data coordinate system in the x, but use the axis coordinate system in the y. And this transform is what the x-axis does for us. If you think about the x-axis, it's in charge of the x limits, right? Knowing the limits of your data that it will draw, but it's in charge of mapping those to actual units on your plotting interface itself, on your figure or your set of axes itself. And so it actually has this really convenient transform that enables you to take data coordinates and map them into axes coordinates to create a blended coordinate system. So when I plot this, you'll see that I'm highlighting, of my histogram of data, I'm highlighting the mean plus or minus 1 standard deviation in the top plot, plus or minus 2 standard deviations, plus or minus 3 standard deviations in the middle and bottom plot. You can see here that I'm again using this fantastic mosaic interface to map, right, how many standard deviations I want to highlight. And if I wanted to add just one more layer, all I would need to do is add 4 to create another column, to create another row, and all of a sudden, bam, I have plus or minus 4 standard deviations highlighted, which, I mean, that's not that useful. That's going to be all of your data. You saw what 3 looks like. That's 99.6% of your data for a given normal distribution. But we can use these things to title, to create meaningful interfaces and inferences into our plots. And now I hope you've worked with Matplotlib before and you're looking at this and you're saying, rectangle with a x-axis transform for a blended coordinate system. Cameron, ax.vspan does that same thing. ax.vspan is implemented like this under the hood. Create a rectangle, use a blended coordinate system, use x as the data coordinates, your y corresponds to axes coordinates, and that is how ax.vspan, ax.vlaines work under the hood. It's not some magic. It's not some magic that Matplotlib is doing for you. It always has to map to some type of physical or some type of concept or idea that Matplotlib lets us implement. And by understanding those ideas, you can make sense of how Matplotlib works under the hood and to make fine-tuned adjustments to your plot wherever you want them when communicating results. And that thinking, that understanding of how is Matplotlib drawing this? How does it know, right, to map data to coordinates and what coordinates I want to use? Because it makes these very intelligent, smart defaults and then adds a convenient access layer on top of them so you don't have to think about them. But by not thinking about them, we keep this tool almost in a black box format in this opaque, this is just a visualization toolkit kind of thinking. But by exposing this to you and just understanding, right, I would obviously use ax.vspan in this case, but I understand how it works under the hood, and if I ever want to make changes to a vspan, I know how to update my coordinates. I know how to change the color because it's giving me back a rectangle. It's just an artist. And so when you think about Matplotlib to orient everything, you have to go back to thinking about artists in terms of primitives and in terms of containers.